Hello, National 5 Chemists. It's Mr. Morton here. I hope you're all doing really well. Today we are marching on with the Unit 3 topic and looking at fertilizers. Now, the information I'm going to give you in this video will link up on to page 21 of that new booklet that's been handed out to you. So make sure that you have that at hand. Now, what we want to be talking about today, as I've said, fertilizers, and hopefully by the end of the video, we'll appreciate just how important fertilizers are. We'll understand three essential elements required for plant growth, and we'll also talk about what makes a fertilizer, or what makes a chemical rather, a good fertilizer. And additionally, we'll talk about one more very important chemical called ammonia and tell you about a little bit more about that. Let's start to talk about fertilizers now. And I'm sure that you all already know that fertilizers are used to stimulate or encourage plant growth. I'm sure that's nothing new to any of us. But what you might not be aware of is just how important fertilizers are in feeding the world's population. Now, there's roughly, I think, about 7.7 billion people on the planet. Without fertilizers, if we didn't have them, we would only be able to feed 40% of those people. So 60% of 7.7 billion people wouldn't exist without fertilizers. That's just how important these chemicals are. So important for stimulating plant growth, such as crops, to feed ourselves, to feed animals, etc. So really important chemicals. So then how do these fertilizers actually work? Well, if we just take a plant, for example, and just think about what we already know about plants. What do they need in order to not just survive, but thrive and grow? Well, one of the most important things they need is obviously some sunlight to help with photosynthesis. They also need some water to come in from their roots, again, to help with this photosynthesis. And so where do fertilizers fit into this picture of sunlight and water? Well, fertilizers are just chemicals put into the ground that plants can absorb when they absorb their water. And in actual fact, it's a lot more complicated for a plant growth than just having some sunlight and some water. They require some what we would describe as essential elements. Elements that if they didn't have, they just wouldn't be able to survive. So if we can give them these essential elements, then they're going to grow better. And that's exactly what fertilizers do. So there's three essential elements for plant growth, and they are potassium, phosphorus, and nitrogen. So three of them to remember: K, P, and N. So potassium, phosphorus, and nitrogen. And essentially all fertilizers aim to do is to provide the plant with these three, or one of these three essential elements, just to help stimulate that growth. Now, you can't just put these elements on the leaves of the plant and expect it to work. The only way they work is if they dissolve in water and the roots take up that water, which contain these essential elements. So it's very important that if we're making a fertilizer, we need to tick two boxes, essentially. So to produce a good fertilizer, there's two boxes that have to be checked. One, does it contain the elements K, P, or N, potassium, phosphorus, or nitrogen? And if it does contain at least one of those, is it soluble in water? So if I know, or if I think to myself, have I made a good fertilizer? The question is exactly that. can I tick both of these boxes? Does it contain my essential elements? Well, if it contains at least one, then yep, okay, it's on the right track. But if it's insoluble in water, it's just going to stay in the soil. It's not going to go into the plant. That'd be useless. So they need to be soluble in water. Now, you could be asked this question: is a chemical a good fertilizer or not? Now, the first box is easy to check because we can just look at it and see what elements it's got in it. But checking whether or not it's soluble in water, well, that would involve us going to page 8 in our data booklet and checking out that table of solubility where it has all the I's for insoluble, VS for very soluble, etc. And if it's soluble or very soluble, it's going to be a good fertilizer. So, two things there to remember about fertilizers. Now, a nice way that I've always used to remember these three essential elements is remembering them in this order: K, P, and N. And the reason for that is this little snack here that I'm sure you've seen before. KP nuts, that's the way I remember the three essential elements. K, P, N for nuts, KP nuts. It's just, there's nothing to, this has nothing to do with fertilizers, but it helps remember these three essential elements for plant growth: potassium, phosphorus, nitrogen, and hopefully that will help you remember them as well. KP nuts. Now let's apply that knowledge to these four compounds and ask ourselves, could I use these compounds as a fertilizer? Would these help stimulate plant growth? And remember, there's two boxes that we need to check off here. First one, does it contain at least one of those essential elements, K, P, or N, potassium, phosphorus, or nitrogen? And then secondly, using page 8 in the data booklet, and here I've got it here, we need to decide whether or not it's soluble or insoluble, because if these compounds are insoluble, then they're no use to us. They have to be able to dissolve in water so the plants can take them up through their roots. So let's look at these one at a time. First one we've got is ammonium phosphate, and if we took our time to work out the chemical formula for ammonium phosphate, which you all should be able to do if you go to page 8 and look at ammonia, which is NH3, and phosphate, which is PO4, and then do SVSDF and swap them round. We know that we need 3 ammonium ions for every 1 phosphate ion. And then we go through our checklist. Does this contain these essential elements? Let's write them in the order that we've learned them. K, P, nuts, right? Does it have any potassium, phosphorus, or nitrogen? Well, yeah, it's got nitrogen and it's got phosphorus. It doesn't need to have all three. It does not need to have all three, just needs to have one of the three. So, good. Okay, that's ticking the first box, if you will, for becoming a fertilizer. It's got an essential plant growth element. Second thing, is it soluble in water? So, ammonium, there's ammonium and it's bonded to phosphate. So, in the ammonium row, I'll go along until I hit the phosphate column, and it says VS, which means it's very soluble. So this is going to be a great fertilizer for those two reasons. It's got our essential elements and it dissolves in water. Ammonium phosphate is a good fertilizer, or could be used as a fertilizer. Let's think about calcium phosphate now. So chemical formula for calcium phosphate, Ca3 PO4 bracket 2. So would that again be useful as a fertilizer? Yep, it contains one of our essential elements. I've got some phosphorus in there, so yeah, okay, I'm ticking that box. It contains an important element, but is it soluble? So there's calcium, go along the row until we hit phosphate, come to I this time, it means it's insoluble. This would be not useful as a fertilizer. It contains an essential element, but the plant cannot take it up. It doesn't dissolve in water. It can't get into the plant. It's no use. What about potassium phosphate? Well, potassium phosphate is K3PO4. Again, it contains some of our essential elements. KP nuts, it's fine. It's got 2 out of the 3, which is great. Is it soluble in water? Down the column along to, yep, potassium phosphate. Again, would be a very good fertilizer. Let's take the last one, sodium chloride, NaCl. Is sodium chloride soluble? There's sodium, go along to chloride. Yep, very soluble. Okay, but I can't use this as a fertilizer. It's useless. It does not contain any potassium, any phosphorus, or any nitrogen. So no, not good fertilizer. Same with the calcium phosphate, not a good fertilizer for different reasons. This has the essential elements, but can't dissolve in water, and this is the opposite. It doesn't have the essential elements, it does dissolve in water. They're both useless. We need a chemical like ammonium phosphate or potassium phosphate to be a good fertilizer. And the last thing I want to discuss in this video is a very useful compound that you need to know a little bit about, and that's ammonia. Not to be confused with the ammonium ion, which is NH4 positive that you've seen on page 8 of the data booklet before in that little table at the top. Ammonia and ammonium are different. So ammonia is a stable chemical compound which is NH3. So this is what we're looking at here, ammonia. Now ammonia is useful, or very useful in fact, for making fertilizers. And as I said, it's got this chemical formula, one nitrogen, three hydrogens. That is a must know. We need to know that ammonia has this chemical formula. Let's just straight up learn this, please. And the shape of the ammonia compound is this pyramidal shape. Again, we've got this nitrogen with three hydrogens coming off to kind of make it look like a little bit like a kind of pyramid. So why are they useful for making fertilizers? Well, if I take ammonia, which is kind of alkaline, basic, and I react it with an acid in a neutralization reaction, I'll produce a salt and water. Now that's something that we already know: acid plus base, salt and water. But the salt produced in neutralization reactions with ammonia, those salts are very good products for fertilizers, very good at making fertilizers because, as we've seen before, they contain the essential elements required for a fertilizer and they're very soluble in water. So let's look at a little example here and what I'm talking about. If I take this chemical ammonia, NH3, and let's say I react it with, let's just say, some hydrochloric acid. Well, what am I going to produce? This is a neutralization reaction, so I'm going to produce a salt and water. And the salt that I'll produce from this reaction is going to be ammonium. Notice how I've changed from ammonia into ammonium after the reaction. This is no longer just NH3. Over this side we've got NH4, and that would be bonded to some chloride ions because I've used hydrochloric acid. So I'm producing ammonium chloride plus water. Now that ammonium chloride will contain one of our essential elements for plant growth, K, P and N, in a salt form, which is also soluble in water. So just by taking that starting ingredient or reactant, if you will, ammonia, undergoing a simple neutralization reaction, we can produce very easily some fantastic chemicals that can be used as fertilizers because they're always going to contain an essential element, and they're always going to be, or 9 times out of 10, they're going to be very soluble in water as well. So using ammonia, we always tick both those boxes that we want from making a fertilizer. Let's look at another example just to round us off here. Again, if I take my ammonia, which we'll remember is NH3, let's react at this time with some nitric acid, which we should know the chemical formula of as well, which is HNO3. And what will I produce on this side of the reaction? Well, I'm changing my ammonia into the ammonium ion, and since I've used nitric acid this time, it's going to be ammonium nitrate. and water. And again, within this salt that's being produced, this ammonium salt being produced, I'll contain one of my essential elements. It's going to be soluble in water, very useful for making fertilizers. So ammonia is a new chemical to us. We need to know, first of all, its name, the fact that it's different from the ammonium ion. It's NH3, not NH4 plus. It has a pyramidal shape, and I can use it to make, again, some useful fertilizers for the reasons that I've banged on about all video. So what we'll want to do in the next video is looking into ammonia in a little bit more detail, but specifically how to make ammonia. And that's via a process called the Haber process, which is an important process in chemistry, and it's an important process in the world because it helps make fertilizers. Okay guys, I hope that video was useful, and I look forward to seeing you real soon.